everyone. I'm Mark Tewksbury, your host for this program. Our goal is to reveal the methods and materials that turn out the products we see around us every day. There's a whole new world of things waiting for us to discover here on How It's Made. We're all familiar with those perfume strips you open in magazines, but how do they put those odors into paper? Simple. The odorant is trapped inside thousands of microcapsules that, when scratched by opening the paper, release the perfume. Maybe simple, but very effective. On today's show, plastic bags, solar panels, plastic gas containers, and hockey sticks. If you buy cat food or snack foods or save leftovers or go Christmas shopping, with all their various uses, you can really get carried away with plastic bags. The plastic bags we use every day are made from granules of linear polyethylene resin that will be melted. They combine the linear polyethylene with another low-density one in this mixer. The granules are perfectly blended into a homogeneous material. Granules melt in the extruder, which heats them to a temperature varying between 180 and 240 degrees centigrade. This produces a film of polyethylene in the form of a tube. It is several hundred meters long, has a minimum thickness of 37 microns, and a circumference of 51 centimeters. The plastic tube gradually cools down. Rollers then flatten out the plastic tube. The polyethylene film is now easy to work. And now they cut the tube on two sides to obtain different rolls. This knife then cuts the film to the required width. The excess strip is salvaged in this tube. Several hundreds of meters of film are produced and rolled up. This particular roll contains the required quantity of film. When the roll is full, the film is cut. This roll moves forward and can be transported to another department. An empty roll begins to fill up automatically. A full roll weighs 158 kilos and can produce 35,000 bags. The next step, printing on the bags. This alcohol-based ink circulates continuously to retain its viscosity. Impressions are made by inking rollers. Here, another color is being applied on the bags. Once printing is over, the plastic film is rolled up again. The roll is now full and the cutting of bags can get started. This machine makes 150 bags per minute. A sealer bonds the edges of the bag together with heat. The wheel picks up the bag and puts them on two spindles that can hold 250 each. Here they're making bags with a hermetic zipper. The zipper is made from a plastic pad which inserts into a slot. The zipper is made in advance and is unrolled progressively. The zipper strip is cut and heat bonded to the bag at 180 degrees centigrade. And here's the zippered bag all finished. In this other department of the plant, they make plastic bags with handles. Printed bags circulate on these rollers. The machine that welds the sides gives the bags the desired shape. Then another machine with a punch cuts the handle holes. Bags are heat sealed and cut at 150 degrees centigrade. Here they fabricate another product, packaging bags. One end of the bag is heat sealed. This machine makes holes which let air out of the bag when it's being filled to allow them to be generously filled with items. At this stage, a stamper cuts the handle holes. Bags are cut to the required size, automatically sealing the other side of it. This plant makes 8 types of bags for an overall total of just over 1 million a day. Once largely ignored, non-polluting solar energy is now increasingly being captured in panels and stored in batteries to help heat buildings and generate electricity. Welcome to the future, under the sun. The sun is able to produce electricity. Panels covered with photovoltaic cells convert sunlight into electricity. This blue plate is a module made of crystalline silicon. The grooves are the conductors, and the silicon crystals glisten at its surface. To make a solar panel, several modules have to be connected together. Then they apply a soldering flux on each module. The soldering wire is heated with an iron. The modules are placed on a special support. Once the soldering is done, the modules are cleaned by ultrasound in water at 60 degrees centigrade. When dried, the perfectly clean modules are ready to be assembled. Now they can proceed with soldering the modules by groups. First, a flux is applied